There you go.
Try this again. Average rates of change. That's kind of what we were talking about the very first day. Remember when we were talking about
No.
average speed?
Yeah.
Oh,
yeah.
The rock falling. Yeah. Well, this is identical. It's just, instead of in context now, we're just thinking of the function. So an average rate of change, that would be like how far you went divided by how much time it took, right? Or the change in y divided by the change in x, right?
Mm-hmm.
So, like if we had a function f of x equals x to the third minus x,
She's gonna like pass
we wanted to find it. Okay, don't mind me. What is it?
Drugs.
They're
They're
like
dealing
brown
drugs on video.
It's meant to
Ew.
Don't suck on it too hard. Choke it.
So if I want to find the average rate of change of that function over the interval 1, 3, what do you think I should do?
Why do you put those in brackets?
Because you can.
That's the proper way to do
It's
it.
just how you write it, like from
That's just how they did it in here. That's fine. I didn't really think about it. That means inclusive, right? Remember
So it's saying over the interval 1 through 3.
that? Yeah, including 1 and 3.
Oh, just one and.
Not the point one.
No, not the 0.13. It's an interval. 1
through 3.
Through 3.
Yeah.
So 1, 2, and 3.
And 1.5.
Okay.
Blah, blah, blah. Everything from 1 to 3. So the average rate of change. So what do you think? How do you do this, Andius? Change in y over change in x, right? Remember that?
Oh, yeah.
So kind of like slope. So what would the change? How would I calculate change in y?
Plug it
Plug what in?
The 1
High
and 3.
extent.
Yeah.
The 1 and 3. So basically f of 3 minus f of 1, right? Over 3 minus 1. Right? Change in y or change in x. So that would be what? 27 minus 3, so 24 minus 0 over 2, be 12. You with me? I bet you they can't even see this at all in the video, I swear.
It's there.
You can see it?
It
I
shows
think it's just
good.
when I upload it. I'll try to do it in HD. It'll work.
Well, you have all weekend on it.
Yeah, I'll do it at home, on my home internet, maybe it'll be better.
It takes like, it took me 7 hours, so I was like a 45-minute video. On my house.
7 hours?
Maybe you just gotta give it time.
Yeah, maybe I'll just turn it on tonight when I go to bed.
See what happens when you
Wake up in the morning, there was like one box you forgot to press.
Okay. So this next part, they're kind of showing you, it's a different graph, it's not this one. But it's the same idea, I don't want to draw this. It's just, here's a function in the blue line, and then it's saying, basically, find the average rate of change from the 23rd day to the 45th day. So it's like slope, like we just said. The change in, they're calling it P on here and T down here for flies. I don't know why they use P, whatever, it doesn't matter. So the change would be, right, we would calculate, we do 340 minus 150 over 45 minus 23, right? And that's change. Do you know what that line is called, the black line?
Tangent.
No.
It's
Secant line. The secant line is basically a line that hits a curve in 2 spots, goes through like that. Not that important. We are going to get to tangent lines, though. What is a tangent line? You remember what a tangent line is?
Kind of.
It doesn't touch you.
So it touches a curve at exactly one point.
Mm-hmm.
Okay.
really important.
So, yeah, then when they just calculate average rate of change, not a big deal. Okay, that's for if you wanted to know the average rate of change from like day 20. This was number of flies, days, like the flies were getting bigger, and they said, how does it change on average from the 23rd day to the 45th day? And you do the average rate of change, and you get about 9 flies a day. It's going up, right? We don't need to read the whole story. Okay, but then the question changes to, what if I want to know how it's changing on the 23rd day? Like not between days 23 and 25, or 45. Like that's the average rate over that whole time. So
We've done
how about on the 23rd day? It's kind of like that we did with the rock.
Yeah.
We said, with the rock, we said, what's the average speed from when I dropped it to 2 seconds? That was one part. But now, then we said, okay, what if I want to know how fast is it going at 1 second?
It is the lapse time.
It's the same kind of concept.
It's instantaneous.
But that was speed. This is different a little bit. So for this, we're going to use the idea of a tangent line. And so what they've done here is, here's that curve. Instead of, to figure out what's happening on day 23, they just took points for Q here and started it moving it closer and closer and closer. It's kind of the idea of a limit, you know, we're approaching here. So then it becomes, you know, once I do that, you eventually get down to, okay, now these 2 points, you can make it to where it's tangent to that curve. And if you know the slope of the tangent line, that's how it's changing on that day. Does that make sense?
No.
Not gonna lie.
Okay.
I'm good.
I-
It feels like I almost have it, and then it's just like,
Okay.
We're not doing anything yet, I just want to get the idea across. On this one, the slope of the secant line was the average rate of change, right?
Yeah.
Yes.
On this one, it's still the same thing. The slope of the secant line here is the average rate of change between this point and this point.
Okay.
The slope of this secant line is the average rate of change in this point and this point.
Yeah.
As we move this point closer to this one, we approach the tangent line, which just touches it at that point. The slope of that line would be the rate of change on that day. Does that help?
Okay.
So
How do you determine how long the line is?
it's a line, it goes forever.
I know, but why does it only touch, how is it there, does it only touch at one point? Because over at 0, it's still,
Here?
no, go down. Like, those lines all touch the other line. They go through it.
Oh, they hit it again?
Yeah.
We don't care, we're just looking at average rate between these 2 days. See,
So as long as it doesn't touch again between those two.
they calculated the first one, the slope of that line, 8.6. Then they calculated the slope of that line, right? The slope's getting bigger and bigger as I move this way, right? Remember, slope goes up.
Because then it touches once.
We don't care what happened in the past on this problem.
Okay,
It's just,
so it's not an uptake.
slope's getting bigger and bigger as we move this way, right?
Mm-hmm.
If we can find the slope of the tangent line, which just hits at that
Oh,
point,
looking at that,
that would be the change on that day.
But it doesn't just hit
Well, no, well, eventually, yeah. You'll get steep enough to where it only hits it at one point.
that. Okay.
It's not drawn on here. Well, AB kind of is. It's kind of dark, though, kind
Okay.
of. Remember tangent? Okay. So, here's how we find the slope of a tangent line to a curve. That's the whole idea of it, is to find how something is changing on that specific day. So let's say we actually want to do something with that. So, let's say we got just our, I'm going to switch to the pen, but I lost my pen.
It's behind you.
Let's say we got a parabola. Michael's x squared. Does a parabola have a slope? Or if we have a line like y equals mx plus b, I can say, what is the slope? And it's the same all along the line, isn't it?
Yeah.
So that's one of the things you learn in algebra. So does a parabola, it
Nicole might not know that.
gets, it gets steeper and steeper and steeper, right?
Mhm.
So it's constantly, the slope or the steepness of it is constantly changing.
But you can find the slope of it at a single point.
That's what we're going to do right now. Basically. So basically we're going to take y equals x squared and find the slope at the points 2, 4. Okay. I'm going to draw a little better picture. Here's my parabola. We'll call that 2, 4 right there. No, my scales aren't the same, but that's okay. Well, there's the point 2, 4. If I want to know the slope at that point, I need to find the equation of the tangent line, right? Okay. So in order to do that, think about the secant lines. If I took a line and went from here to like here, that would give me the average slope between these 2 points, right?
This makes a lot more sense.
So what I want to do is move this point as close as possible to that in order to get the slope at that very point, right? You're frowning like...
No, I'm just listening.
Okay. I know. This is important. Okay, so here's what we're going to do. Before we did change in y over change in x, we're still going to do the same thing. This is our point 2, 4, right? So now this point, I'm not going to give it specified coordinate. I'm not going to call it like 3, 9 or anything like that. This is going to be, here's 2. It's going to be some distance away. We don't know, right? Like this could be anything, but I'm going to move it closer. So I'm going to leave it as a variable because it's going to change. Like I want it to be really small. So I'm going to call this point 2 plus h, just h being anything.
Is there a straight line right there?
The pencil one?
Yeah.
Yeah, should be. My drawing's not very spectacular.
Is it going to one?
Is it going through what?
One, or is it just like?
It may. I don't know. It doesn't matter. Because I'm going to move this point, and it's going to eventually be tangent right here. So this point's just 2 plus h, h being anything. I want to make h really small. Do you see where the limit's going to come in here? We want h to approach 0 so that we can get the equation of the line right there. We want h to become relevant. If h is 1, right, this point's way out here, and this is right here. But as I move this point closer, isn't it getting close? Isn't the x value getting closer and closer to 2? So I want h to approach 0. So if that's 2 plus h, what is the y value?
4 plus h. 4 minus h.
Close. How'd you get that? Or 4? Oh. No. I see what you did. You just took that 4 and added h. It doesn't work. How do we get the y? If I take 2, how do I know what the y value is?
I'm given it 2 plus h squared.
Yes, that's right. That's she's right. If I take 2 and I say what's y for this function, you would say 4, right? You would square it.
2h squared.
Yeah, so I gotta take the x value and square it. So this is gonna be 2 plus h squared. That's that point. So now, let's do our slope. Changing y over changing x. So changing y is just the difference between the y's, right? So I have 2 plus h squared minus what? Let's see if you're on the same page. Okay, what is it? 2 plus h? 4.
Sorry.
Over
2 plus
2 plus h minus
2.
2. So we can clean this up now.
Why is it minus?
Y what?
Why is it minus?
Slope is changing y over changing x, right? Change meaning
Right.
difference.
Okay, got it.
So we're subtracting that. So let's take this. I'm going to move down here a little bit. Obviously 2 minus 2 on the bottom, those are going to go away. So I'll just have h on the bottom. This is the same as before. 2 plus h squared. Got to do FOIL. It's not 4 plus h squared. Right? 2 plus h squared, 2 plus h times 2 plus h.
4 plus 4h.
4 plus 4h plus h squared minus 4.
4 drop out and you lose the h.
Huh?
Or you lose one of the h's.
Oh yeah, it will. I got a 4 and a negative 4. If you got questions, say it.
Well, she helps me. I'm good right now.
Okay. So we got 4, we're just cleaning this up. 4 and negative 4 are gone. So, and I'm going to rewrite it. H squared plus 4h over h.
Drop that h.
Let's factor an h out and drop it. So it'll be h times h plus 4 over h. So the h's will drop. So I would get h plus 4. I don't like the numbers they use because
Now I am confused.
what?
No, I'm not. Okay, I thought that was 2th. Never mind.
No,
I like multiply, no.
It won't always be.
it won't always be 4 plus h. That's why I don't like the number. Like I said, I don't like the numbers they picked for this because that was just luck. So that, what is that? What did I just find?
Change from y over change from x.
Yeah, the slope of that penciled line, right? That's the slope of the secant line. Okay. So if that's the slope of that line, and like I said, in order to make a tangent, I want this point to come down and get really, really close. What am I doing there? What's happening to my h value?
It's getting closer to 2.
It's getting close to 2. Well, h isn't getting close to 2. Remember, here's 2, 4. Here's 2 plus some number h. So as I come down and I get really, really close to 2, what's happening to h?
It's close to 0.
It's getting close to 0, isn't it? If I'm moving this guy down, the x value of this point is getting really, really close to this one. So h is getting close to 0. So let's take the limit as h approaches 0, because we want h to get close to 0, of h plus 4. That should be an easy limit to calculate. What's that limit equal?
4.
Just 4. Again, I hate the numbers. I should have done it differently. Should have thought about that a little more before I did this one. So what is that?
What's your slope?
That's the slope of the tangent line at that point.
The secant line?
tangent,
The tangent.
where it just hits, that's because as we get really, really close, it goes to 4. So if I could draw a line that just barely touched that parabola at one point, that would be the slope of the line.
Wait, so then it would always just be the y?
No,
No.
that's why I said I don't like the numbers.
Oh.
That was just luck. That was just because it's x squared and a 2 and a 4. It just happened. If we chose different numbers, or on your homework you have to do this, it's not going to just be the y. It's different. So that's the slope of the tangent line. Let's find the equation of the tangent line. So if I actually wanted to graph it, what would I have to do? If that's the slope, what do you need to know to find the equation of the line? Slope and y-intercept to get in the slope-intercept form. Okay, but I know the slope. Do I know anything else about this line?
You know, 2 points.
I know it goes through the point 2,4, don't I? So now can I find the equation? Do you remember how to do that?
Just drag it back down to the,
You could do, if you wanted y equals mx plus b.
Well, that's what I was doing.
That's what you're used to.
You plug in a point.
Plug in your point. So 4 equals, plug in your slope, plug in your other x, and now solve for your y-intercept. It's just like algebra 1 days.
Equals 4.
Good afternoon, I have a couple of
Should we make it
announcements. If you're planning to go to tonight's football game in Ritzville, please take a lawn chair because their bleachers have not been installed yet. And also, students, please stop by the office during lunch or after school to pick up your pictures. Thank you.
And
It's just
then
for
my
what?
ASB schedule for it.
Oh.
So there we go. If I were to graph a line, if I were to graph y equals x squared, and then graph the line y equals 4x minus 4, it would touch it exactly right there, and that is the slope of the tangent line at that point.
Homework.
Homework time.
Sure.
I had more. I could keep going. I was ready today. Once we get rolling.
Third period, you were.
Third period. So I'm going to have to put the homework back because we didn't get to everything.
So
So,
you're good into that homework?
yeah. 2.4, quick review, 1 through 5, and 3, 5, 7, 12, A, B.
You can go with it.
What?
Who doesn't do, just A and B?
Just A, B, because you don't know the C and D yet.
Do we have papers that we need?
Oh, yeah, you
The pop please? The pop please. The pop please.
Here you go. Here you go.